Morning students, let's continue with the testing again. So in the few lectures back we have discussed about the basics of testing. Then we discussed about the types and levels of testing. Further we discussed the test case design strategies that were two. The first was your black box approach and the second was your white box approach. Now further we have few more topics relevant to testing that are left to be discussed. Let's continue with that. So we have to discuss what is debugging. Why debugging? Because debugging is an integral part of testing. Until unless debugging is there, testing is insufficient. Remember, the objective of testing was simply to identify the presence of the error. Okay, fine, you have compiled the code and you have identified the error. But if you're not going to debug it, that is eliminate the error, it's of no use. We have to make our software error free. So debugging is a complementary activity of testing, or it works hand in hand with testing, right? So debugging is what? Debugging is a process of identifying the exact location of the error and then fix those errors. That means eliminate those errors, right? The simple process of identifying the error in the program code and then fixing them up is known as debugging. So what is the difference between the two, debugging and testing? So testing normally focus on finding the errors in the bugs, while debugging starts after a bug has been identified in the software. Then we go on identifying the exact location and then eliminating it. So testing is used to ensure that program is correct and it was supposed to do with a certain minimum success rate. Testing can be manual or automated. So what do you mean by manual or automated? Manual means that we do with our hands without any tool. But automated is when we go on using some testing tools for performing the testing task, which could be done very easily and less time and less effort will be required for that. So that is automated testing. So few tools if I name for testing is a Selenium, it's a QTP. Likewise we have so many tools which assist in testing. Normally, but when it is a simple or a you can say startup companies, there we normally go for manual testing. There are several different types of testing. Like we have already discussed the unit testing, integration testing will be doing next, alpha and beta will be doing it now. Now, debugging requires a lot of knowledge. So, it doesn't mean that debugging is a simple task. It's a very critical and a complex task. You must know the knowledge of entire software which is under development, about the requirements, about the designing, about the code, and the testing skills and expertise is definitely required. So, it can be supported by some automated tools available, but is more of a manual process as every bug is different and requires a different technique. So this is what I said. Normally we go for manual until unless any company forces us to automate our test, right? So manually things are different. Now there are certain debugging approaches. So I said debugging is simply locating the error and then eliminating it. So we have few approaches to locate the error, that means identifying the exact location of the error in a code. The very basic method is known as brute force method. What is a brute force method? In this method, say you have a code of 10 lines. So what we will do, we will add extra printf statements in the code. Extra means normally what is there? We write a code and then we at the end we have a printf statement to get the output. But this method says you have to load with extra printf statements. Say after each line or after each alternate line, you can add a printf line just to check the intermediate output, right? So what happens is, say after one line, then the output printf line, then another line, then again a printf line. So you can check the intermediate output. If you find the intermediate output is not correct, so the only statement is which is an error is the statement which is above that printf line. right? So you have identified the error in the sixth statement. So the possibility of error is in the fifth statement, because till fourth statement the intermediate output was correct. So this is how the task of identifying the exact location is can be simplified by using extra printf statement. But what happens when you add extra printf statements? The size of the code increases, and as the size increases, the effort required, right, to understand or to test or to maintain the code, or the time required will increase. And when effort and time increases, definitely the cost will also increase. So this is a basic method to understand the concept of debugging, but it is rarely used method because it is not at all efficient. The second method, which is practically used, is a backtracking method. What does the backtracking says? Say you have written a code and you identify certain symptoms of the error, right? The source code is traced backward until the error is discovered. Let's assume we have a 10-line code and I identify the error symptoms in the 7th line. So what I'll do is I'll start backtracking from the 7th line, then the 6th line, then the 5th line, then 4th, until unless I identify the root cause of the error, and then I go on eliminating that root cause, so the error will be eliminated. So this is what is backtracking method. But there is a problem associated with the backtracking method. See, when you start backtracking it, say from the 7th line then to 6th line, in the 5th line there is a function call. In the 4th line again there is distinct function call. So whenever there is a function call, you have to go to its definition, and then you have to again backtrack or trace those definition lines also. For the fourth statement, again it is a function call. You have to traverse those lines also, the definition of that function call. So in the backtracking method, the number of source codes, or you can say the number of source line and the source path or the code path, it becomes more. So it becomes a complex task. So we have one more method. First I'll discuss this program slicing because it is similar to backtracking. We have just modified backtracking. We call it as a program slicing, just to reduce the scope of the backtracking lines. So what is done in backtracking line, or you can say program slicing? So you identify the error in the 7th line, right? So we check which variable is an error. For example, variable, right? Say a variable is an error. So I will start backtrack, but only those lines which are influenced by variable a only, right? I'm not going to traverse the line where B variables are used or the C variables are used. I will be only backtracking those lines where A variable is used, because error is present in the A variable. So instead of backtracking the entire source of lines, I have sliced it. Slice means a subsection of program is being created with the help of these variables, the influenced ones, right? So you can see it is similar to backtracking. Search space is reduced by defining slices. So a slice is one slice for A variable, another slice could be for B variable, third slice could be for C variable. So a slice of a program for a particular variable at a particular statement is a set of source lines preceding this statement that can influence the value of that variable, right? So almost similar to backtracking, just we have reduced the scope of source lines that needs to be backtracked. Now another method is a cost elimination method. So what do you mean by a cost elimination method is try to identify the root cause of any error and eliminate it instead of eliminating the symptoms. What does it mean? Say if you suffer from fever, normally what we do is we go and directly take the paracetamol or crocin to suppress the temperature. But once the effect of the medicine goes off, again the temperature rises. You again take a crocin, again the fever comes down or the temperature comes down, and after few hours again it reverts. So why, if you're taking a medicine, why the fever is not going? Because might be the reason of the fever is something else. It may be some sort of infection in the body, right? So once you go and seek a doctor's, like you can say, prescription. So what he says, he you for 2 or 3 days he'll give a normal medicine for the fever. But still, if the fever is there, then he asks for some pathological test, right? Blood test could be there, urine test could be there, and a number of tests could be there, just to identify if there is infection in the body, because temperature rise could be related to some infection, right? So once you get those pathological report, the doctor identifies what is the root cause and he gives the medicine for that infection, not the temperature now. He gives the infection for the infection. He gives the medicine for the infection, and once you take that medication and infection goes off, temperature itself comes down. So this is what is said here in the cause elimination. Never go on eliminating the symptoms, that is rise in temperature. It won't work at all, right? Go for identifying the root cause, eliminate that root cause, and the results will be better. Take another example. Say I have to include header file, and then I'll be using functions of that header file. Right now, I forgot to include that header file, and I made a code, right, using, say, I forgot to write stdio.h in C, right, and I'm using printf and scanf statements. So it will give the error once you compile it. So what we do is we try to modify the statement which is in error, but it is a symptom. There is no error in the syntax of that statement whichever you have written, but you hit in trial and try to modify that statement, but it never works because the root cause was the header file was not included, right? So if you directly go and include the header file, the error symptoms in, say, 4 or 5 lines where printf and scanf is used, it itself goes off. So this is what is meant by cause elimination method. Now, starting with, we were discussing about the levels of testing and we did the unit testing. Now the second type is your integration testing. Now we assume that in the module dependency graph, say M1, M2, M3, M4 and M5, say we have a module dependency graph where we have few of the modules. We tested each and every module in isolation in unit testing. That means all the modules were individually tested and there is no error in the module. But what happens is the overall functionality of the system is achieved when you integrate all those modules, and the entire functionality is achieved, overall functionality of the system. That means once you go on integrating these modules, it might be possible that the error occurs. Why the errors it occur? Because these modules are sharing some parameters, right? And when you integrate these modules, maybe there is a compatibility issue or a mismatch issue which might happen in these parameters, so error could arise. So integration testing is to test the module interfaces. That is, there is no errors in the parameter passing when one module invokes another module, right? These are basically relevant to the design errors, right? Design error because these module interfaces were designed in the design phase. Now, different modules of a system are integrated in a planned manner using an integration plan. Now say let's assume we have a module dependency graph where M1 module is broken down into M2 and M3. M2 is broken down into M4 and M5, a tree-like structure, right? So now we have to integrate these modules. So how do we integrate? That depends upon the integration plan. What is an integration plan? It specifies the steps in the order in which the modules are combined to realize the full system. So steps means it may be a top-down way or it may be a bottom-up. You start integrating from the root module till the leaflets are being integrated. This is known as top-down approach. While if you start with the bottom modules and then you go on combining them till the root is achieved, that is bottom-up approach. So we have different approaches for integrating them. Overall, that is present in your integration plan document. Now, what helps? The structure chart or the module dependency graph. helps us in achieving this. Now, integration testing approaches. We have four distinct approaches for integrating them. The first one is a Big Bang approach, second is a top down approach, third is bottom up, and the fourth one is a mixed approach or a sandwiched approach. So, what do you mean by a Big Bang approach? Big Bang approach is when all the modules in the system are integrated at once. That means if there were 5 modules and we integrate all the modules together, right? That is on a larger scale, Big Bang. But what is the problem associated with this is when you integrate all the modules together and say some error is there, then you need to identify which interface is in error because they are, say M1 was broken down into M2 and M3, so there is an interface. M2 was further broken down into or decomposed into M4 and M5, they too have an interface between them, right? So let's say 4 interfaces were there. So you have to check each and every interface for error. So the time required will be more, right? So this is what in you can say the problem associated with the Big Bang integration testing, right? Let's see, it's not practical or least practical, or it is applicable only to a smaller system only. This was the reason, and it becomes expensive because effort required will be more. If effort required is more, time will definitely increase and cost will also increase. So what is opted then? If you're not supposed to integrate all the modules together, then how to proceed with the integration testing? Integration testing is actually done in steps or in a gradual manner. What do you mean by steps or a gradual manner is we integrate any 2 modules at a time and we test for the error, right? So if any error is present, the only possibility of the error is the interface that these 2 modules share. So it becomes simple. Now you don't have to test for other modules or the other interfaces because you just integrated 2 modules, right? Once you test and eliminate the error here, then you integrate with the third module, right? Then again, what is the possibility of the error if error arises? The one which is recently added. In that interface, the error will be present because the previous ones were already tested. So eliminate it, then add the fourth module, likewise add the fifth module until unless all the modules are gradually added and tested, right? So this is how the integration testing is done. But how to proceed? How gradually, which steps to follow? That depends upon top-down or bottom-up approach. So in the bottom-up approach, we start with the lower modules and we combine, say that is M1 divided into M2 and M3, M2 into M4 and M5. So what I'll do is I'll integrate the last 2 modules first and then I'll test it. Then with the M4, then with the M1, then with this. So I'll start with the the bottom modules and move towards the root module. So what is the primary purpose? The primary purpose of testing each subsystem is to test the interfaces. It can be a control interface or it can be a data interface between the modules. In large software, lower level subsystems are successively combined to form a high level subsystem. Right? Now, what is the advantage of this bottom up testing? The advantage is there like several disjoint subsystems can be tested simultaneously because say you have multiple branches which are further decomposed and multiple sub branches are formed. So parallelly you can start with these subsystems separately and at the end finally you can combine them together. So this is a basic advantage. Now, what is in a pure bottom-up testing? Now remember, in the unit testing we have seen that we require a test environment where we require the drivers, the top module and the steps, the bottom module and some global variables. So in case of bottom-up, right, what is required at the bottom? Stub. What is required at the top? That is driver. So just compare if you have a module dependency graph and you have to start with the bottom up integration, which all dummy functions are required. Do we require stubs? No, because in the bottom up approach there is nothing at the bottom, so stubs are not required. Yes, we have the modules at the top, so we require the driver module, right? So some of the effort can be reduced because now stubs are not required to be developed. We only require test drivers in case of bottom up approach. Now, what is a major disadvantage? The disadvantage is the complexity that occurs when the system is made up of large number of small subsystems. So it becomes time consuming. Now, the third approach is a top-down integration approach. Top-down integration approach is we start with the top level modules, that is the root module, and then we move towards the bottom modules, right? And keep on testing them. Now, top-down integration testing approach requires the use of program stub. Stub is the bottom. Since you are supposed to move from top to bottom, so the bottom ones are required, that is the stub is required. In this case, the drivers are not required, right? A pure top-down integration does not require any driver module because there is nothing above the root module. Now, what is the disadvantage then? Since you are starting with the root module, right? It's not necessary the root module is always ready, because when we are coding it, we normally go on coding the simple functions of the modules first, and then we make the overall program, right? So the overall program is developed at the end finally, right? Now you're supposed to go for top down, and we know that the top module is always developed at the last, right? So this becomes one of the problem in case of you can say the top down approach. And the second problem is you start with the top module, but input output operations are always provided by the bottom modules, that is the leaflets. So until unless you get the input, how you can perform the testing of the root module, right? So again it becomes a problem. So what is a better approach then? It's a combination of both, that is top down and bottom up approach. We call it as a mixed integration testing or a sandwiched testing, right? So how you can use it? We use the advantage of both the approaches. For example, in a top down approach, testing can start only after the top level modules have been coded and unit tested, while in the bottom up approach, testing can start only after the bottom level modules are ready. These were the constraints with the top down and the bottom up. So in the mixed approach, this shortcoming is overcome. How? In the mixed testing approach, testing can start as and when modules becomes available. If the top modules are available, we'll start with the top down. If the bottom modules are available, we'll start with the bottom up. So we can use the advantage of both the methods, the top down and the bottom up, and we can proceed with the testing. So the most commonly used integration test, you can say the strategy is a mixed integration testing strategy. Then we have another two categories. One is a phased and the second one is an incremental integration testing, right? So what is the difference between the two? The name directly suggests incremental means you are adding one module at a time and you are testing it in increments, one at a time. You add one module, you test it. You add another module, then test it. You add another module, then you test it. That is incremental, right? While phased is when a group of modules are added together. Let's assume in the module dependency graph, the layer 1 has M1 module. Layer 2 has M2 and M3 modules. Layer 3 has M4 and M5 modules, right? So a modules could be n number. So in incremental, I'll add only one module at a time. But in the phase, I'll add all the modules in a particular layer. I'll call them as group of modules. That is, say M2 and M3. Both of these modules will be added to M1. Right? That is phase. In a phase or in a layer, all the modules are added together, right? Then in the next step, I can add M4 and M5 to the previous ones. So that is known as phased integration testing. That is, a group of related modules are added to the partial system each time, while in the incremental, only one new module is added to the partial system each time. So And notice here, a phased integration requires less number of integration steps. Like it's true, when you're going to add a group of modules together, so ultimately the task will be completed very early, because instead of adding one module, we are adding a group of modules. So all the modules will be added quickly. However, when the failures are detected, it is easier to debug the system in the incremental testing, right? Increment one at a time. So if there is any error, so we can easily identify, because we just added one module, so one interface is there. But in the case of phased, we add multiple modules at a time, so you have to search in which interface the error is there. So it is easy to debug incremental, since you're adding one at a time, right? So the next level of testing is a system testing. You have unit tested it, that means each and every module is properly tested, there is no error. Then we have done the integration testing, that means interface errors are also eliminated. So what is system testing? System testing is to validate the complete system, whether it fulfills all the user's requirements which are present in the SRS document. So this is done in three ways. Accordingly, we call the system testing is of three types: the alpha testing, beta testing, and acceptance testing. Alpha testing is when the development team members carried out this type of testing in the development organization. That means in the development environment only. That is alpha testing. While beta testing is when the testing is performed by friendly customers or the potential users in the end user's environment, right? While acceptance testing is carried out by the actual customers on the real world data in the customer or the end user's environment. And here the decision is made whether to accept the system or to reject or ask for modification. That is why the name given is an acceptance testing. So this was your system testing. Then one more type of testing is there. Now we knew that in this RS document, we have written both functional and non-functional requirements. Till now we have seen all the testing times which were focusing on the functional requirements only. Then what about the non-functional requirements? Are they not supposed to be checked? Yes, if it is a banking software, I need to check whether it is secured or not. If it is a mobile operator, I need to check how other services it provides, that is availability or the connectivity, right? So these non-functional requirements actually governs the quality. So it is mandatory to check all these non-functional requirements also. So few of the non-functional requirements which are tested are using these testing types. So performance testing is basically divided into these 9 types, right? There are many, but we are discussing the few of them here. The first one is known as a stress testing. So what do you mean by a stress testing is when we give inputs, right, or the number of users are increased beyond the capacity of the system. Overload our system, stress it, right? Say for ISCTC website, it is meant for say 10,000 users can work simultaneously and book the ticket. But we knew at the Tatkal timing or during the festive seasons, along with the Tatkal timing, the number of users drastically increases. Say 50,000 of the users are trying to book the ticket, right? So that is stress. So we need to check how efficient our system is to deal with this overload. It should not fail, it should not hang, it should work, right? So this is what stress testing is. We also call this as endurance testing. So stress testing evaluates system performance when it is stressed for a short period of time. It imposes a range of abnormal and even illegal input conditions so as to stress the capability of the software. It could be the large volume of data, it could be data rate that has been increased, it might be the processing time, or it may be the utilization of the memory. So beyond the capacity, we are supposed to check that. So this is like one more example for multi-program system is given, like we have discussed the ISATC example. Then what is volume testing? Right, volume testing, you might feel these two are same. Stress means again we are increasing the data, and the volume will also mean the same. No, there is a distinction, right? Here we are checking the system performance when we are going to stress the system for a short duration of time, while this volume testing is something relevant to your data structures, right? We know that, say array has a capacity, we define it. Say I have defined an array A and the capacity is 5, right? Now I give 10 inputs, right, beyond the volume. So how it is going to behave, right? So if this happens, maybe it is a case of an array or a queue or a stack, right? In that case, if you're giving more input than the capacity, then it must show an overflow condition, right? Symbol table overflows are there, right? So it should be represented. Then the next one is the configuration testing. Configuration system testing is to check whether our system behaves properly in different configurations that it is supposed to run. Right? For example, the hardware configuration. Whenever you are preparing a software, we always specify the minimum configuration of the hardware which is required for it to execute or run. So it must be there, right? It must run on that specified configuration. That is configuration testing. Likewise, we have software configuration. Remember, in the RUP model, we have done software configuration management, where we have to manage all the deliverables or the softwares or the documents which are released, right, using version control system or the change management system. So we have to test all the hardware configuration as well as the software configuration specified in the requirement document, that is SRS. Then compatibility testing is whether our system is compatible on different platforms, right? Say if it is, you can say we require the system interface with other type of system, right? Say you go for chatting, so it must be compatible. Or you want to transfer the data from one system to another and they work on different platforms. So are they compatible, or you require any sort of you can say the transformation. For instance, if the system needs to communicate with a large database system to retrieve information, compatibility testing is required to test the speed and accuracy of data retrieval. Right? How speedily it is giving and how accurately. It's not that the data gets corrupted in the process. Another type is the regression testing. Regression testing is something which is basically a part of maintenance. Whenever we go on making certain changes, but yes, it is a part of testing, right? So regression testing is to check those modules which are not supposed to be changed, are they working properly as they were before the change was implemented, right? Understand it this way. Say I have a module structure M1 divided into M2 and M3. M2 is divided into M4 and M5. So I want to change this M2 module. There is certain error. Okay? So I made the changes, I compiled it and tested. So that is a normal testing. Okay, wherever you make the changes, you compile and test it. It's the normal black box testing or the white box testing you'll carry out. Black box, whether functionality wise it is correct. White box, whether any syntax or semantical errors are there. Okay, fine. M2 is tested. But when you're making changes in M2, it is sharing parameter with M1 at the top and M4 and M5 at the bottom. Say you changed a variable. Now a variable was shared with M1 also and say M4 also. So with the change, it will have impact on the other two modules. M1 will also have some effect of this change, while M4 will also get some effect. But when the change was required, the change was only required in the M2 module. M1, M4, M3 and M5 was correctly working. We does not require any change in those modules. So there must be something which checks whether other modules which were not supposed to be changed, are they working properly? So this is done by the regression testing. So regression testing, now listen carefully, is to test those modules which are not supposed to be changed. Are they working properly as they were before the change was implemented? This is regression testing. Okay. So in that case, you have to apply all the test cases you have early developed, with few new test cases need to be developed for the changed requirement. Now, what is recovery testing? Recovery testing, as the name suggests, if in case certain problem occurs in your system, is it able to recover from that situation? Maybe it is the fault, or it may be the loss of power, or device crashes, or any service is not fulfilled, right? Any reason could be there, any such fault occurs. So when you again restart your system, whether it regains to the original position or the data is being lost, right? So we say that it must recover from that situation, right? So system is subjected to the loss of the mentioned resources, and it is checked if the system recovers satisfactorily. So it must recover actually. Then maintenance testing. What do you mean by maintenance testing? We have seen recovery testing was a part of maintenance. Then what uh, is different here? Maintenance testing. Okay, tell me, how do you know your system needs a maintenance? Whether it is your laptop, whether it is your desktop or your mobile, how come you know that you need to update it, or and there is certain error you have to rectify it, right? This is, say, let's take a simple example. You have WhatsApp. Now and then system updates comes, right? Key updated to this new version, because there might be certain additional features in that and you won't updating it. That means there is some mechanism by the software or the application which indicates the user that this change is required. So we are talking about all those diagnostic programs and procedures. These are known as diagnostic programs or procedures. Any pop-up that comes in your system that this is required to be done, or you need to update your system, or you need to add this patch, antivirus, you need to add the patch, right? So are these diagnostic programs and procedures present in your system or not? And if they are present, are they working properly? So this is what is tested in maintenance testing. This should be actually present and work properly and accurately. Then documentation testing. Documentation testing is to check all the required documents, may it be a manual, user manual, beginner's guide, maintenance manual, installation guides, or any technical manual, whether they exist, that is, we have prepared, and are they consistent, right? So we need to check all the documentation must be complete and accurate. Lastly, that is usability testing. Usability testing is to test the user interface. What is user interface? Like you can say the browser, say that is a user interface between the user and the internet. So that is, we have to check the interface whether it meets all the users requirement and users are able to use it properly, right? That is why we had graphical user interface, because it is more understandable instead of character user interface. So that is user friendly. So actually we need to check whether the system is user friendly or not in case of usability testing. So this was all about your testing. Thank you guys.